Hi, I'm back. So, looking at investment and the profitability of an investment, do we want to do it, do we not want to do it? We have the final method to calculate whether or not we have a profitable investment. The final method is called Payback method. And I think it's fair to say that when we look at all of the methods that we have looked at so far, the Payback method is going to be the most simple way to calculate whether or not an investment could be profitable. So let's look at what we're going to take a look at. I'll just explain to you the Payback method like I did in the previous videos and what it's all about, and then we'll go directly into Excel and create an example together. So, as I said, it's very simple. The Payback method is all about to measure the payback time of the investment. And the way we measure the payback time of the investment is to calculate the number of years it will take for the investment to pay back using its annual net payments, the return, to cover the initial outlay. So how long would it take for the investment to pay back for itself using the net payments, the return that the companies expect to receive? We do that in two ways. We do that in a way we call static, where we do not take the calculation rate into consideration. And then we do it in the dynamic way, where we do take the calculation rate into consideration. Now, as I have explained previous and we talked about in class, the calculation rate is something that we use because money loses value over time. So thereby also said that the static method is not the most correct way, or at least it's not the most precise way to calculate the profitability of the investment. But we will do a little discussion of that in the class as well, because it's probably the most used way to calculate the profitability of an investment among companies. And we will talk about why this is the case. So we always have these profitability criteria. So the profitability criteria for using the payback method is that if the investment is recouped, paid back within the lifetime that we have set, the technical lifetime, the investment is considered profitable. That simple. So let's try this example together that I've created in Excel, and then we will discuss it later in class as well. So, as I always also did in the previous cases, I have cheated a little, so you might want to press pause and recreate what you see here on the screen regarding the Excel sheet that you see here. This is just a thought of example. We have made as a company some sort of investment in a machine, could be of 700,000. Now currency doesn't matter yet, so it could be kronos, could be euros, never mind. And the change that we expect, the change in our income that we expect to receive because of this investment should be 200,000 a year per annum. We have set the technical lifetime to this machine to be 6 years. Now there is a simple way to calculate this. How long does it take, not considering the investment calculation rate, how long does it take to pay back this, to recoup this initial investment of 700,000? So the most simple way, of course, is to say, well, we have 700,000. We pay back 200,000 a year. How long does it take? 3.5 years. Now we do not consider the minus here in front. So, but of course we can, and we must, it's not always the case that the change in income is a fine number like the 200,000 you see in this case, and therefore we cannot always use this, and we cannot use average numbers to do these calculations. So therefore we set up the table that we have set up so many times before using the other methods. You know the table by now, this table, where you have a column for the lifetime or the year that we're in. We're starting with year 0 for the initial investment, and then the lifetime down forward. And then we have a column for the investment, a scrap value, if we consider a scrap value, the change in income. We sum up these two columns, this and this, and we get the net payments. So we need to add a fifth column to calculate whether this investment will pay back for itself within its lifetime. And what we do is that we accumulate these net payments. Now, the first year we have nothing to accumulate with. We only have the investment of the 700,000, so we just add that into, in this case, if 10. So, but for the first year, we have had the income from the first year to pay back on the 700,000. So here we are taking the 700,000 from the previous year, that's the initial investment value, and we simply add the net payments of the first year. There you have it. So now we have 500,000 left of the initial investment, and let's take a look at that if we do that here in year 2 as well. So we had the 500,000 from the previous year. Now we have made 200,000 the change in income. Enter. So now you know the formula, the calculations. So we simply just copy it forward, and you can see, just like we calculated up here, 3.5 years. Take a look at this. Somewhere in between year 3 and 4, the investment has paid back for the initial investment with the change in income. Exactly, you can see here that it is exactly between 3 and 5, because minus 100,000 is exactly the same distance from 0 than 100,000 down here. So I would call that a simple method. But we also know that we have this calculation rate. Money loses value over time. So we need to consider that these amounts here are not directly comparable with the first initial amount in year 0. So what we do here is we use our discount factor that you have seen in previous lessons and in previous videos to calculate the net present value of our net payments by using this small formula that I have set in here. So what I do here, the formula that you know, and by the way, I have set a calculation rate in this example to be 13%. So what I do here is to say, my present value, my net payment for the current year multiplied with my discount factor, which in this case is with 13% of interest, and I will fix that cell because I'm going to duplicate, I'm going to copy the formula down forward. Now remember to fix it with the F4 on a normal keyboard, or Command T if you have a Mac computer, or simply just write the dollar signs manually. And then uplift it in minus n. Remember, I want to take it back in time, so therefore we need a little minus in front, and then of course the year in. Now when we uplift something in 0, the number is going to be 1. So 1 multiplied by minus 700,000 is still going to be minus 700,000. So here's the formula. And now I am simply just copying the formula down forward. Now what went wrong here? What did I do wrong? I did nothing wrong, sorry. No, so what you see here are the present values of the net payments. So the 200,000 in year 2 would have had the value of 156,629 in the year 0. So what we do here, and that's where I made the mistakes because I thought that's the column that I was in, is I accumulate now the present value of my net payments. Look at this. Same as before. The first year, or this year 0, I don't have any income, but the second year, the previous year's present value of the net payments, and adding the current year's net payments, present value of net payments. Enter. And now again, I'm going to double click over here to make it copy it down the total column here, all of the column. And now you can see it does make a difference whether or not you take the calculation rate into consideration. Of course it does, because money loses value over time. Now here it says that somewhere in between year 4 and 5, we have paid back for this investment. And we can also see that it is definitely closer to year 5 than year 4, because 100,000 is further away from 0 than 3,000. Now, When we have the situation that the payments we receive is a fine serial of identical payments like this, we have a function in Excel that we can use to calculate the exact amount or the exact number of years here. Now this function is called NPER. And you might want to take a look at the internet if you have a different language than Danish or English in this case. So you should get this picture. The first thing it's asking for is the calculation rate, and the calculation rate I said was 13. Now the payments that I'm looking for here were the 200,000, which was the initial change in income. So I will write the 200,000 here. And then the present value of what we have to pay back at the moment are these 700,000. So rate, payments, and present value of the initial investment. Press enter. So now you can see 4.97 years is the payback time, taking the calculation rate of 13 into consideration, which is very close to what we can see over here. If you do not have the possibility to use the NPER function, it is an okay answer in an assignment in a case to write that the investment will pay back, recoup in between year 4 and 5, closer to year 5 than year 4. It's a totally fine answer to answer it like that. So that would be the payback method, and we will discuss it more in class and do some cases and assignments together and then Q&A, so that you are totally up for this last method of calculating the profitability of an analysis. See you.